Okay, so remember I told you that transformations unit, you're going to use it in like most of the remaining units. So here's another example, right? We did it with radicals and rationals, now with trig functions. So it's a big part of that. So we have to remember all of our transformations. Yes, even though you can enter a function into your calculator to see the graph, we still might ask you to sketch, to do a graph of a trig function. Probably not that many times, maybe once on a test, but for sure you're going to have to be able to come up with an equation. So given the graph, figure out what the transformations are, and then write the equation. That you can't do, right? So if you could take a photo and have it like spit out the equation of it, that would be like photo math, which some of you might know about. Teachers don't like photo math, but in any case, I don't know if it does it for actual graphs. But, so let's look and review the transformation. So we're going to start with stretches. So y equals a sine theta. So the a is just like an a value in any graph, right? That's your vertical stretch. If it's negative, also there's a reflection. So if you replace y with y over a, then you're going to have y over a equals sine theta, which almost always in this trig unit we always solve for y. We rarely leave it in transformation form. So then solving for y, there's your function. So now you can graph it, right? If it's y equals, you can put it into your calculator. So that is the original, vertically stretched by a factor of, well, a could be negative, so we're going to say absolute value of a, just to make sure. Okay, now, if that absolute value of a is less than 1, so that would be like a half, or 0.7, or 0.9, or something like that, so it's less than 1. That's a vertical stretch by that factor. What does it look like when you graph it? Is it going to be stretched out or compressed? It's going to be compressed, right? So we sometimes say there has been a vertical compression. That's just describing what it looks like. We always just keep to the vertical stretch by a factor of whatever. Vertical stretch by a factor of whatever. Okay? If it's bigger than 1, then we call it a vertical expansion. And again, it's just describing what it looks like, not describing the transformation. Oh, I guess I should have put expansion first. We'll do this. Then it goes with the A and M. And then if A is negative, right? A less than 0 means it's negative. There's a reflection in the x-axis.
There's no y-axis reflection that stretches about the... No?
Yeah, we don't.
Can they happen?
Oh, we do stretches about the y-axis, but not reflections. We'll get to that in the next one.
Does that actually change it? About the y-axis? Yeah. Reflections of the y-axis. You can just refer to those as because it's saying...
yeah, it does change it, but we don't do them.
Oh,
okay, so cross out the features listed below that do not change when you start with your y equals sine theta and you stretch it vertically. Then circle those that will change. So cross out or circle. So amplitude, that's the height from the midline to the top. If I vertically stretch, does that amplitude change? Yes. Okay. So circle those that will change. Period is horizontal. Will that change? No. Midline is the x-axis. If I'm stretching it, it's about the x-axis. So that doesn't change. If we do a translation, it'll change, but not a stretch. Domain is horizontal, so that does not change. Range, if I've changed the amplitude, I've changed the range of it. Theta intercepts. No, because that's on the horizontal x-axis, so that does not change. Y-intercept. Now, think about it. It should change, but what's the original y-intercept? For sine. For sine, it's 0. 0 times anything is 0. So this will not change because the original y-intercept equals 0. So just be aware that that's something, if you're doing a vertical stretch, your y-intercept will change if it's any other point than 0. So, the nice thing about this word amplitude is it starts with the letter A. What's that letter there? A. That's the amplitude. Nice. Thing is, amplitude is never negative, so we should put absolute value signs if we're talking about amplitude. We need those absolute value signs. Okay? So now, if your original graph, if now you've stretched, so here's your sine graph. Now I've stretched it like this. Has my range changed? Yes. This is now my, this is A, right? And this would be negative A, if we knew what A was, right? So the range now is between those two values. So we have to have y less than or equal to the A value. Now, if A is negative, we have a problem leaving it like that. We should have absolute value signs. Okay? Just to keep it as amplitude. So y is less than the amplitude and greater than negative of the amplitude. Okay? Negative outside the absolute value symbols.
I mean, if A is negative, multiplying by like the negative number, wouldn't that just flip the signs anyway?
So if A was negative 2, then it would look like.
Yeah, but that would have to flip the signs because they're. Or we
so we wouldn't want to put negative 2 without the absolute values there because then it can't be less than it, right? So we need the absolute values. Just for the general.
Oh yeah, because the range is.
Okay, so what are the invariant points? Notice where all those graphs that I drew, are they the same? Sorry, are they invariant? Yes. And what are they? They're the original theta intercepts. Okay, so
Calculate the area of like that.
area is integration.
Oh, that's calculated.
Okay, so in this one, I want you to grab. I think we put in. Just make sure. So in your notes there, it says sketch the graph of y equals a half sine theta and y equals 3 sine theta. Change that to negative 3 sine theta. Okay, so you're going to do a reflection as well. Different color for each. So think about what you're just doing vertical stretches. So a half sine theta, you just said, are theta intercepts. So this is theta here. They don't change. Okay, and then we're multiplying every y value by half. I'm just going to do the important points. So I'll do the original max. So if y is 1, now it's going to be a half. Negative 1 is going to be negative a half, positive a half, negative a half. And then do the best curve through there. Sinusoidals are not straight lines, so do not make it a bunch of V's. Use an eraser so that you can fix it a little bit if you need to.
Also, don't use a pen.
Like, don't use a pen, exactly. Unless it's erasable. If you're asked to graph on an IB exam, you're allowed to use pencil for the graph.
But nothing else.
Correct.
Why?
So it doesn't touch.
But don't they scan it and send it in?
They do, but sometimes scanning doesn't show up very well. But you are also not allowed to use pencil. I would still like
You use eraser pen on the exam?
No.
That's what is even worse though. Just friction and complete. You can't see it.
Okay, so that's y equals a half sine theta. It's vertically compressed. Negative 3 sine. So if you think about stretching, so again, actually, these still stay the same. And then we're going to stretch the original by 3 and then reflect it. So really it's like multiplying 1 by negative 3. Negative 1 by negative 3 is positive 3. I'm better at this when I'm on like regular paper. You don't want to see this. No vertical lines like that.
How do you get like a sinusoidal graph with like, it's like basically, you know how it's not parabolic, but like, you know how like it's curved and then a parabola is curved? How would you take like, you know, an absolute value function which is like straight and then make that sinusoidal?
How would you do that?
Yeah, like what is the equation of a graph that looks like this?
I don't know. Piecewise. There are some. I don't know.
Yeah, and then it's just like for when, you know, between these values, when this is this, then it's,
Yeah.
okay, got it.
For right now, I mean, there are some. But... Okay, so amplitude. So if there's nothing in front, it's a 1, right? And we know the range is between negative 1 and positive 1. Now for half sine theta, amplitude is a half. Negative 3 sine theta is positive 3. They're going to ask you, we're going to ask you, it's going to be on the final exam, you have to know, because students will say the amplitude is negative 3, and it's not, amplitude cannot be negative. Okay? Your range is between negative a half and positive a half. You can use, actually, interval notation is a bit faster for range. So here you could go from negative 3 to positive 3 if we use interval notation. Okay. Okay, so that's vertical stretches. Now horizontal. A little bit harder in some sense in terms of graphing it. As it notes there, we're keeping B being positive. So we're not going to do a horizontal stretch and then reflect it about the y-axis in this course. So you don't really have to worry about that. B, we're assuming, is positive. So for all these questions, I'm not going to have absolute value because we're assuming B is positive. In real life, B could be negative, right? But we're not going to, it's not part of the course. So if we replace theta with b theta, the resulting equation is just as is. There's nothing you can do to simplify that. Okay? But if we replace theta with p theta, then it's a horizontal stretch, or horizontally stretched by a factor of, remember, the reciprocal. Okay? So reason your way through these questions, just like on a multiple choice part of a test, right? What's b? B is back up here. So if b is a fraction less than 1, then what is happening? So is that going to be compressed horizontally or expanded horizontally? Expanded, because think about it, if that's a half theta, you're vertically stretching by 2, which is an expansion. So expansion horizontally kind of gives it away. We did in the notes, but whatever. Okay, and then if b is bigger than 1, so then say that's 3 theta, then you're stretching by a third, which compresses it horizontally. It's just what it looks like, yeah. That we always describe the specifics without using the word stretch. This is just what it looks like. Okay.
We put like compression on a test every month.
If you say compressed by factor of a half, then I don't know what you mean. Do you mean multiply by half or multiply by 2? Okay, cross out the features that do not change, circle those that will change. So, amplitude is a vertical thing. It's not going to change. Period, if you're stretching, folks, too much chatting. If your period is 2 pi, think about it being a piece of wire that's in that one cycle. If I stretch it, that wire is going to stretch out. Same, so that period that I now have is going to be longer, right? So the period's going to change because it's still the same amount of kind of wire in a sense. So that period is going to change. Midline doesn't get changed by either of these unless you do a translation. So that's not going to change. Domain is not going to change, but why isn't it going to change in this sentence?
It's all real numbers.
All real numbers. It goes to infinity. If we restricted the domain and then did a horizontal stretch, yeah, it would. But just the nature of the sine graph, it goes on forever horizontally, so the domain actually will not change. Range is vertical, that's not going to change. For sure, these theta intercepts will change. They're going to move, right, because you've stretched them. So that will change. And y-intercept will not change, okay, because that's the stretch is about the y-axis. Okay, so now regular graph has a period of 2 pi. So again, here, if I do a regular graph, there's 2 pi. Okay? If I stretch that by 2, it would end up, that point there would end up being over here. Okay? So that would be, if I stretch by 2, it would be 4 pi. So, when I talk about a vertical stretch by 2, what goes into B? A half, right? So what can I do to 2 pi and a half? So I've got 2 pi is your regular period. I've got a half as my B value. How can I end up getting 4 pi with those numbers? What operation would I use? Division, yeah, because if you divide by a half, you flip and multiply, right? Okay, so this is going to be 2 pi divided by b. That, I would say, memorize it. Okay? That's the period. Yep. So you're going to use this. If I give you the period and ask you to find B, rearrange that, right? So really just, I mean, we're not doing that yet, but just to realize then B is equal to 2 pi divided by the period. And please don't ask me how that works because it's just rearranging the formula. And you're 30-1 ID. You can figure it out on your own. Okay. Yeah. So, in summary, this is transformed to y equals sine b. So what of y equals sine theta is an invariant point? So here, this y-intercept, right? Okay, which happens to be 0, 0. And then are we... Okay, so let's graph these two, and then we'll be done for the Friday. Okay? So take a look at the scale. This is theta. This is y. Okay, let's just focus for a couple more minutes. We are going to, so we've given you y equals sine theta. We're going to graph y equals sine of 3 theta. So that's a horizontal stretch by a factor of 1/3. So horizontal stretch by 1/3. Okay, so take a look at your grid markings. So there's your, so that's going to stay the same. We just said that's invariant. Take a look at your intercepts. We have to take that x value and multiply by 1/3. Well, we've split each pi into 6 grid markings. So how many grid markings for 1/3? 2. So that point there is now going to be this point. It's compressed. You're going to get a lot of cycles. We're not going to do all of them. That point goes there. Okay, think up here. This was pi over 2. Okay, stretched by 1/3. What's 1/3 of pi over 2? Pi over 6. That's 1 grid marking. So that goes there. So there's your first mountain. Okay. Then, what do you think about the valley? Is it going to be the same size but underneath? Yeah. So do you really need to look at every point and stretch it? No. This is 2 grid units, so there's going to be another 2 and another, so you can actually do a few. And then this one's going to be down here. This one's going to be up here. This one's going to be down here. And I'm kind of going to just stop there for now. And you can do a couple on the other direction just to get. So notice how I'm not doing any intermediate points, especially because it's small. Okay, but I'm making it curved, not doing straight lines. I know sine is supposed to be curved. So let's check our formula that we came up with. The length of a cycle, so there's a mountain and a valley to there. That's 4 grid marks out of 6. 4 6 pi is 2/3 pi. Okay? If we take our formula, so the period equals 2 pi divided by b is 3, I get 2/3 pi. Okay? But my formula is. Okay, so the period is 2/3 pi, or 2 pi over 3. What are your intercepts? Now, through every 2 grid units, which is starting at 0, which is pi over 3. So it's multiples of pi over 3. N pi over 3. Yep.
Is the n is the n on the numerator pi over 3?
Doesn't really matter. It's not root of 3, right? So you can go n pi over 3, you can go pi over 3n, you can go n times pi over 3. This is a horizontal stretch by 2. So let's get this in before the bell. So your original is the red. Okay, folks, just quiet for a minute or two longer. Original invariant is there at the origin. This point here stretched by 2, that's going to be over here, right? That's pi over 2, multiplied by 2 is pi. Pi multiplied by 2 is 2 pi. So there's a mountain. Okay, then this is 3 over 2 pi. That's going to be 3 pi. 2 pi times 2 is 4 pi. Okay, and same in the other direction. So, looking at that green, that's a mountain and a valley. That period is 4 pi. Okay, so 4 pi, let's use our formula. So the formula that we came up with, 2 pi divided by a half. When we divide by half, that's equal to 4 pi. So by the formula or by the graph, you get the same thing. And then now our theta intercepts are multiples of 2 pi. So this would be 2, you might show it as 2 pi n or 2n pi, because I don't really care. Just have the 2 pi and the n in there somewhere. Okay, so that's where we'll leave it off. So we're going to start part C on Monday.